Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 30, which is nuts. Bug squashing part 6. So we are still working on this this bug that is affecting, well, we thought was affecting Space Squash, but it looks like it's actually affecting Mario Tennis. So we need to dig into there a little bit more and figure this stuff out. Sorry, by the way, for the little bit of a late start. It's only like 5 minutes late, but still. Sorry about that. Just went to the dentist today, and now I have really low blood sugar because I didn't eat in the middle of the day like I usually do. So, yeah. It'll pick up by the time we get going, I think. By the way, hi to guys in the chat. Dark Second, E Higgs Twitch, Metal Voids, Tobez, Mad Moose, Dana Collin. Good to see you guys. So last week we left off by digging into more of Mario Tennis. Darcy said, but your pearly whites are good. Indeed, they are pearlier and whiter. Actually, they're not, but one of them is at least less broken, so that's nice. Head Moose says Ferris eats stuff. Yeah. Shit, why didn't I just stream that? Okay. Last week we left off basically just by in the middle of tearing apart Mario Tennis again. So just trying to take some notes over some things that we've seen, some variables that we saw changing, and just trying to figure out like what is the logic here that it's expecting not to happen in order for the graphics to not get corrupted. So particularly, I want to continue going through here to kind of figure out where is the code that actually clobbers the registers that we care about that are causing the graphics to be corrupted. What is letting that run when it presumably should not be running, which originally I thought it was because the interrupt was firing. But now that we've looked into this a bit more and also looked at the code of Space Squash and did that hardware test a few weeks ago, now I'm definitely suspecting that rather than it being just because the interrupt is firing, I think it's actually because some logic is a bit strange somewhere. So it's not the interrupt itself, but some logic that the interrupt executes. Still not entirely sure yet. Got to dig some more. But yeah, I think this will be useful and helpful. But yeah, I'm still pretty stoked. By the way, this is the 30th emulator stream. Even there's actually even more if you include all the demo streams. I think the last one I did was episode 14. Whoop. Let me check that actually, 'cause I'm curious. So far, I've done 30 emulator episodes, 14 demo scene episodes, and at least 2 whatevs episodes. So I've done like I've done almost 50 streams. That is crazy. But cool. I'm really happy about that. Anyways, time to dig in. So here I have Mario Tennis again. Drew says prolific for a full-time employee. Well, I'm doing this pretty regularly now, so that helps. Two streams a week, especially when one of them I don't really have to plan for. It's not that bad. Yeah, so here we have our corrupted graphics. That's how that goes. Okay, so last week, one of the things that I was looking at in particular, so what we have here, this is the actual VIP interrupt, but it's basically just preserving registers. Preserving a bunch of these, including R11, which is actually a key thing that I thought it wasn't. So it looks like it's R12 and R13, I believe, that we're doing this. I think, where was I had some labels here. So this is where the decompression routine starts and ends. 135C, and that's why I have here, and ends at 81494, which is here. Yeah. So this is the entire graphics decompression routine, and in particular, it uses a lot of So R11 is safe, but R12 is not safe. R13, and I think basically all these registers after R10 and R11. These are getting clobbered. Bad things are happening. R15, basically R12 to R17, it looks like. There's R18. Yeah, R12 to R18 is basically what we're after here. I'm going to write that here. We did see R18, right? Yeah. Drew2 said, by the way, I resumed work on my Vectrex emulator. Awesome, by the way. Inspired by what you've been doing, I've started working on a really cool debugger. I am really happy to hear that, and I would love to see that. Express says, does Virtual Boy have a kernel like whatever Unix? Unix where interrupts fired during a syscall would result in E-enter and stuff like that? I'm not sure what E-enter is. There's no such thing as really syscalls here explicitly. We do have, of course, exceptions, and there are exceptions can happen within exceptions. There's ECR, and I think which is the exception code register, and then there's I think it's FCR, which is like I think it's called duplex exception that can actually happen. So it's error interrupt. Yeah, so I don't think you get an error interrupt, but you do get maybe you do. I honestly can't remember at this point. I can look that up actually. It's definitely not what's happening here. I'm pretty sure. But we can check. I just pulled up the data sheet for the CPU here. I'm pretty sure this was called duplex exception, but searching for duplex didn't yield anything. So let's see. Let's see ECR. Here's exception register. NMI duplex exception status saving register. FEPC. And FEPSW. So when an exception occurs, which is the same thing as interrupts in this case, or interrupts can trigger exceptions, I should say. EIPC and EIPSW, this is your program counter and your status word, which the actual PC and status word will be saved into for that exception. Contents of the PC, blah, blah. And then, yeah, if multiplex exception or interrupt is enabled, then, yeah, we need to save these in the interrupt handler. Bit 0 of EIPC, are these all fixed to 0? Yeah, whatever. Yeah, basically it's just possible for an exception to happen when the exception processing, which is this EP bit, is 1, and then it will fire a duplex exception, which will, like, I think it goes to a specific handler, or maybe it doesn't. I'm not actually sure. I don't remember. There's also a fatal exception, but I think that's different. Let me see if there was a section on exception handling. Going on a bit of a tangent here, but I'm curious. Here we go. Interrupt and exception. Interrupts, blah, blah, blah. Exception is an event that takes place depending on the program execution, but then, yeah, interrupts come from external. There's a little difference between the interrupt and exception in terms of flow, but the interrupt takes precedence over the exception. V810 family architecture is provided with the interrupts and exceptions listed in the table below. If a maskable interrupt or NMI occurs, control is transferred to a handler whose address is determined by the source of the interrupt or the exception. The exception source can be checked by examining an exception code stored in the ECR, which is the exception code register. Each handler, actually, and funny enough, we witnessed that when doing that hardware testing. The code in that standard library was doing exactly that to figure out which exception actually happened. So it used the exception vectors all actually routed to one handler, and it would check the value of the ECR and then dispatch to the individual functions that the user could set up after that. Each handler analyzes the context of the contents of the ECR and performs appropriate exception interrupt processing. Okay, so you actually get a specific handler for duplex exception, I think is what this is. The exception code of the exception that occurs for the first time is stored in lower 16 bits ECR, and then, yeah, get the higher 16 bits. That's the FECR, I think. I think that's it, though. I think you just get another kind of exception. But maybe that's what you're asking? Where interrupts fired during a syscall would result in an E-enter. Yeah, it's basically the same thing, except it's not an error interrupt. It's a duplex exception, which I think normally is an error. But I think there are some cases like if you had a floating point exception within an interrupt handler, where it wouldn't necessarily be an error, but I think most cases it probably would be. I mean, at that point, it really depends on, I guess, how the operating environment has decided to treat those kind of cases. But as far as the hardware is concerned, I think it just has, like when an interrupt or NMI occurs, then we check if that one bit is set. And if it isn't, then we're going to set it, and that's our exception processing bit. We set it and then go to the exception handler. If one of these conditions occurs that would take precedence over that, for example, I think, yeah, so these are like regular interrupts, and so there is also a precedence system here. So like if one of these occurs while one of these is being processed, I think it just gets ignored. But like if one of these, like if you were in one of these interrupts and then a zero division happened, for example, then you would actually get a duplex exception. I think that's it. But I think the only difference is it checks if that one bit is set. And I think there's actually two bits here. Oh, here's actually the entire logic. If the NP of the PSW has already been set, proceed to fatal exception. So the NP is the NMI processing, which I think is what happens when you get the duplex exception as well. If the EP of the PSW has already been set, then proceed to duplex exception. Then we save stuff. Our exception code says EP and ID bits to the PSW and clears the AE. I don't know what the AE bit is. Jumps to the handler. Fatal exception. Cycle. A fatal exception occurs when you have an interrupt that fires if you're in an NMI or in a duplex interrupt, and that can't happen. That's bad news. Duplex exception is safe though. Yes, you get the like extended error code, and then we go to basically NMI handler. Yeah. Anyway. Ehixer says, I think it's sufficiently different from Linux and Unix that it's not a relevant question. But I think it's sufficient to implement what Unix does. And the system even has a timer, so I think you could actually run Linux on the Virtual Boy. Granted, I don't have that much of an overview of what you actually need to run on that, or what to run a sufficiently stripped down Linux kernel, but I thought those were the two things. Was exceptions and a timer. Maybe you don't need exceptions. Or I guess a way to do syscalls. I'm not sure. Anyways. So we're basically looking for places where these registers get clobbered. And there's a lot of these, like if we just search for R12, then we'll find a bunch of these where this is actually used. But I think it was here. That we saw code was actually starting to get executed down here. But I think, was it there I was going to look into, or was there I kind of recall me wanting to look into this 8B4 thing. 8B4. Hey, Don 170. Saxashaw? Not sure how to say that. Your phone's DT770s? Oh, yes. And they're so good. Very good headphones. I bought them because they were recommended to me by most of my audio production friends. And I wear these things for like 8 hours a day. Easy. So one of the interesting things about this piece of code in particular is that it has a jump right before it, which will skip some of this code, but then jump into some other stuff. I'm just kind of looking at the flow here. How it might get to this. I guess, like, if this is a conditional that will jump away from all of this code, if this condition doesn't happen, then there's another conditional that'll jump to 802CE, which is here. Otherwise, it'll jump to this label A, which skips everything. If it dropped into this code, 303C from R10, which is not the same R10, because it's from here. 26R1 was our, registered there. So we can compare these two. $590. You know what I might do? I don't think we set watch points on. I don't think we can set watch points on registers. But I'm thinking I might want to do that. Because it might be a short path to figure out what's going on here so I know I can get this into a state where the graphics decompression routine is running, and then I can trigger an interrupt or wait till an interrupt triggers, and then while we have that interrupt triggering, I can set, like, enable some watch points for the registers, and then at least we could see what code in particular is triggering this, is actually writing over these registers. I think that would be helpful. And then we can kind of see if we have the code in front of us already, or if we have to kind of trace how it got there, which we could actually do just by looking at the link register and kind of follow it back up the stack. So I think that's a decent strategy for this. I still want to be able to understand this at a fairly detailed level to see kind of how it got there, but I guess trying to find the endpoints is probably a good plan here. Dan Collins said, something that is useful is the ability to do register equals value as a breakpoint. Yeah, that's a good point. And also do some more complex expressions, but that gets trickier, of course. Yeah, I think one of the advantages of building the emulator ourselves is we can just kind of hack what we need. So I'm not going to sit here and extend the debugger on the stream, I think, just because this is kind of a specific use case. But I might just hack that. Dan Collins says, yeah, like break if reg 0 is reg 2 plus 2. Yeah, that'd be nice. I think Dirt 2 says, I wouldn't mind seeing that on stream. Yeah, it's not that I don't want to do it on stream. Sorry if I was a bit unclear about that. It's not that I don't want to do it on stream. It's just that I kind of don't want to do it. Like, I want to just kind of hack it first and see if that's helpful enough. Don't always need to do things all the way. Although I did at one point, here. I did at one point set this up. Is the debugger still here? Yeah. To use this combine parser, which actually makes those kind of things a lot easier. Because we basically have to build a little AST for the expression parser there, and then be able to evaluate those. And we'd have to evaluate those at, like, basically every step of the emulator, so it would cover a lot of stuff. So out of laziness, I'd rather hack it. Not because we're on the stream. I don't know why I feel like I have to explain that in such great detail, but that's what I'm thinking. So we know, here's what I'm going to do, I think. How do I want to do this? So we know the range of registers that get clobbered. So I basically just want to like add a watch for this whole range of registers. And I think I need the ability to enable and disable it because like these will be written to during the decompression routine, and we don't want to break on those writes. We want to break on the ones that clobber these from the interrupt. So we want to be able to enable and disable this, and we just want to be able to check this entire range of registers. So I'm just going to add like a new kind of watch point here and just say screw it and just hack it in here. So here's our command parser, and I think we can just add another command here. I'll just even do it at the end. Enable reg break and disable reg break. Also, just to make sure I don't have, yeah, it's just that change. Yeah, so we got clean state more or less on this branch, and that should help. And here we just want to copy something that's easy, like show regs. Dan Collin is saying that he used pests for a couple things, which is probably pretty cool. The fact is, the fact that it's macro based is actually kind of a turnoff for me after using nom for some larger grammars, just because it would produce a lot of errors that were very hard to read. Whereas combine, at least the errors were a lot more sensible. Of course, the other thing I had with nom is I had some cases where the grammar should have worked but didn't. By the way, is this the same E Higgs that's in the chat? Sorry, I don't mean to call you out, but that'd be funny. Yeah, I'll have to give that a shot at some point. For this, actually, we'll call this reg watch. Let's do this. I think we just have, I think this just works. So yeah, so the way I have this set up is I just have these commands that get parsed, and those commands are dealt with the in the debugger. And so if I run this, Russ will tell me where I'm not using this or where I'm not supporting this when I should. That's emulator RS20619, which should be in here. The way that the debugger and everything is set up here is not very clean, but that's fine. It's actually not that bad, I should say, but it's not my best. But it's good enough. And for this, I think I'm just going to do... Yeah, here, for example, we set the CPU actually handles watch points, and we can insert those. I'm going to make a state on the CPU to handle this. So that way I don't have to pass it around. If we're gonna hack it, might as well hack it the fastest way. Let's do reg watch enabled. And so in the CPU, there's our cache. Here we go. Here's our watch points here. We can do pub, reg watch enabled, cool. Then here's the really nice thing, is that I have all the registers. I didn't plan for this. I'm just pleasantly surprised all of a sudden. All of the register rights go through these reg GPR functions. Reg GPR and set reg GPR. So we can basically do this stuff here. And I think, how did I do the watch points? Did I make step a Boolean function to trigger that? Yeah, num cycles and trigger watch point. I'm gonna add I think I can actually just, oops, I hit insert. I think this trigger watch point thing will just trigger how we want, and I should just be able to set that to true. But I probably have to do it through another state because of how those functions are set up. Dan Collins says, isn't it easier to just have a vec of registers to watch? Yeah, I don't want to specify them every time, so I'd rather just compare the range, is what I'm thinking. Because I'm gonna watch the same ones every time, or watch for those same ones every time, I should say. By the way, unrelated, I'm getting really pumped for Silswogen, by the way. Got some cool stuff we're working on. Which should be very unexpected. So yeah, so here we have trigger watch point, and then just starts the debugger. Okay, so great. So this trigger watch point won't do anything else other than just start the debugger. It's just that semantically we've said that this is why. But up here at the top level, we haven't used those semantics, which is nice because then I can just basically do that. I think the way I'm going to do this is take these and make them also return a bool for whether or not they trigger the breakpoint. I think that's what I'm going to do. And I'm also going to print that. So which ones were we looking for? 12 to R18. And new LEA. This is Rust. Sorry about the link smashing Dora 2. Bang Lang works. Also, Dora 2, you should totally be on my whitelist. Let me fix that real quick. Dom170 said, just got the third edition of Computer Architecture, a Quantitative Approach. Congrats. I'm still very pleased with that book. Although right now it's beneath something else because I finally got my FPGA back from the States. So looking forward to playing with that after a couple more projects. You're not on the whitelist yet, Dora2, but I'm logging in there just a sec. Sorry about that. That should fix it. Move around some windows here. Cool. Ah, nice. Drew2 is sharing a link for this awesome talk you watched about Rust, geared at existing systems programmers. Oh, I've actually seen this one. This is a really good talk. This is a really good talk. So this is from July of 2015. This is back when I was starting to get into Rust. Yeah, this is a good talk. Oh wait, why am I doing watches for reading the registers? It's writing that we care about. I mean, generally watch points should do both, but it is writing that we care about. So I'll do that instead. Hey there, Inflame. Yeah, still working on the interrupt. From the last couple episodes, I don't think it's actually the interrupt that's causing the problem. I think it's some logic that isn't set up correctly, or something weird that triggers some logic in the interrupt that is normally not supposed to run, but is running. So trying to figure out what that code is that actually clobbers these registers, and then trying to figure out why it happens and perhaps why it shouldn't, or how to fix that so it shouldn't happen. So short answer, yes. Longer answer, yes, star. Value here. Oops. That should do it, and then we'll return. Right, watch. This, yeah, okay. This is fine. I'm not too worried about using these as floats. Actually, I am. Because they're the same registers, so it's, yeah, still gonna make sense. Right. Do this. So I think the way I do this is I basically do a search replace, I think. Get all these. Whoops, come on. Where do I? Ooh, hold up. Oh, hold on. I'm doing this wrong. Here we go. I need to select this and then extend my selection like this. There we go. And then here, that should have edited all of them. Yeah, it did. So we'll do that, and then we'll do the same thing for... Yeah, that actually got covered already because this is the same. This is just a suffix on the same string. So that should work. Now, there are definitely some points in here where like these were used in functions, so this won't work. But we'll fix that. The 209 had a different problem. Regwatch. $947. Yeah, here, for example. And we can just do this. Sorry. Mute reference bool. And then we can do this. And then wherever we call that's wrong now, which is fine. Do self.add is where this is used. Okay. And F32 doesn't have a hex representation for the float case, which is fine, because there we can just print out the value. In fact, we can even do this. There we go. That should be enough to hack in this feature. Oh, and we we got a breakpoint already, right, to R12. Oh yeah, I didn't disable this when that enable flag, or it's not using the enable flag to actually check whether or not it should use this, which is fine. Hey Zagjev, not yet, just hacking in some watches in the emulator to see when some of these registers were looking for a change. So no progress yet from last time. Or no concrete progress, but you know. Self here. And we'll plop this into the float one as well. Yeah. There we go. So actually that proved that it worked already. But now we should be able to enable and disable that feature. So for example, if I go ahead and hit a break here, then I can do enable regwatch, and I can continue. And there we actually already got some writes. Oh, this is great. Now, I'm still fairly certain this triggers on the instruction before the one that it's actually showing. And I'm okay with that. And we can disable the reg watch and continue, and we're running. Good. So this should be all we need. Nothing more. Nothing too fancy. And I'm satisfied with that. However, I have to use the restroom, so I will be right back. And I'm back with glitchy Mario graphics. By the way, I forgot to mention this. I want to mention this on the stream. Someone put out another Super Nintendo demo. It's a tiny intro. It's 256 bytes. But I want to link this because it made me really happy to see. As far as I know, this is at least the only demo on Poet since the ones that I was doing a couple years ago. And again, I'll get back on this at some point, but that just made me really happy. So, congrats to Revenant who wrote this. In fact, I'm going to run this because I thought this was really cool. It's just made me very happy to see this morning. Where's my emulator? Here we go. Higan hype. Yeah, so it's a classic kind of Keftails effect. But it's 256 bytes. And it's Super Nintendo. So that's awesome. Yeah, Colin says I can run this on real hardware. Please do. I actually haven't yet, but I bet it's nice. I did take a tiny look at this in a hex editor this morning. And I mean, it's structured more or less how I expected. There's some reset vectors and stuff at the top. There's a 32 entry sign table at the bottom. And I didn't really look at the code, but beyond that, I just wanted to see how big that sign table was. Looks surprisingly smooth for 32 entries, so that's pretty cool. Anyway, had to share that because that was pretty cool. Dan Collins says he's actually getting a Sony PVM tomorrow for some proper retro gaming coding. What's PVM? What is that? You have officially piqued my curiosity. Oh, yeah. Oh, it's one of those awesome monitors, isn't it? Man, I want one of those. I want one of those so bad. I'm so jealous. Yeah, I really want one of these. Cuz I love the form factor. Yeah, I really want at least one of these. I have like a 20-inch TV that I use, and I actually hate it because it's so big and it's not CRT. So congrats, I'm jealous. Dan Collins says it looks awesome, and yes, they do. They always look so good. Because I mean, they're broadcast monitors, so they really proper output. Using a CRT for that stuff really does make a difference. However, I will also say that I do have a capture card that I've tested out recently for this stuff. And that also works pretty well, but you do have a little bit of latency. Which doesn't really matter for demos, but still. Oh, man. And here's a picture of what your setup is going to look like, and I'm even more jealous. Oh, I hate you right now. Bagger says, oh, that thing is sexy ugly. Oh, yes, it is. I'm going to leave this tab up. See if I can find any on eBay after this. Metavoid says, I have a FlexScan F56, no PVM, but nice anyway. Oh, I have to Google that as well. Drew's going to make me more jealous. Oh, yeah. This is Drew 2 screen. Oh, this is classic. Dora the Explorer monitor. That's awesome, man. Oh, FlexScan F56. Oh yeah, this is proper late 90s or early 2000s. I can't really tell. Then Colin says these are easy to find on eBay, but hard to get people to ship them. Yeah, that makes sense. Actually, now that you mention it, I did have a buddy who worked at a. I wonder if he still works there. We'll see. But yeah, that's awesome. I think it, no, won't say anything more. Middle Voice has got it for free from my uncle's basement. Nice. That would have been a much different comment if Daru had said that after showing the Dora the Explorer monitor. Daru 2 points out that John Carmack's huge monitor back in 95. I didn't even know that 1080p was like a thing then. That's awesome. I love the look of this. It's so ugly. Oh, this makes me happy. And here I am on my 43 inch. So Jeff says that must have been heavy as shit. Totally. I like being distracted on this stream. The one I'm getting is 16 kilograms. How big is that? Oh, I'm so jealous looking at this picture. I know this isn't even your setup, but I know that you have a SNES and you're going to use it with this. Someone has that, and that makes me jealous. 14 inch. Oh, it looks so good. Looks so good. Look how crisp that is, you guys. I know that we're watching a YouTube video through the stream, through all that stuff, but this is insane. Look at more workplaces. Oh, I like your setup, Metal Voids. I had a picture of mine, actually. I should bring that up as well. I'll show yours, Metal Voids, while I find mine. This is important, guys, for the emulator. Express is asking about if PES is annoying because the compilation errors and macros are harder to read. That was one of the problems I had with NOM, at least. I did try PEG at one point. I used it for, I can't remember what I used it for. I remember being pleased with it though. Don't remember. Oh, Middle Voids, your picture is in the same thread as the poet thing that I'm looking for the picture of my setup in. I just noticed. Here we go. Well, okay, so technically this was my setup. Bagger says for the FPGA lang thing. No, I was using a Parsec for that. I was doing that in Haskell. But a voice says note the Atari ST in the background. I definitely saw the Nintendos. I did not see the Atari ST. which is awesome. This was my desk. Now it's basically the same but shifted, and everything is on the opposite sides. But yeah, if you guys are ever curious, this is what my setup looks like. Except again, kind of mirrored because the N64 is on my left now. And I moved everything to... You can kind of see it over here. There's another desk back here. I moved everything onto that desk near my shelves. Anyway. Too bad it says Emulators A3X. No, these are the A5Xs. And the next one the next ones I'm gonna get are the A7Xs because they are just so awesome, and these don't have very much low end. But these are also very good, so I don't really feel like I need to upgrade yet. But yeah, they're good monitors. I tried to do music production fairly seriously for a couple of years, so that's why I have a lot of this audio production kind of stuff. Right now, they're just super good because they sound great. I mean, in a really balanced way. I'm kind of picky about that. But yeah, these are my A5s, and I really like them. Too bad it's high frequency orgy. Yeah, the little tweeters in there are really nice. Actually, what I need to get for them, though, is I need to get little stands so that they're higher, because right now they're a bit low. And I'm kind of used to that by now, after having used them for so long. But sometimes I have to like bend down to really hear a clearer picture. I guess I can tilt them up as well. Get some of those stands, but because I have stuff on them, I'd rather raise them. Too bad says I prefer Genelec. That's fair. That's fair. Anyway. Yeah, so let's actually make this happen. So I need to set a breakpoint in the graphics decompression routine, which is going to be here. We're going to set one at the end as well. And we're going to continue until that fires, first of all. Yeah. We're going to cause that by switching screens, and bang, there we go. So this is at the beginning of the decompression routine. The next thing we're going to do is we're going to set up a interrupt handler set up a breakpoint in the interrupt handler. And then we're going to continue until we hit that. And we didn't. We actually got the other side of the decompression routine. But I bet if we hit this a couple times, here we go. 292. Yeah, this is the interrupt handler. This is exactly this here. So at this point, we're in the interrupt handler, and I want to first set a breakpoint at the end of the interrupt handler. Down here. And then I want to continue, but before that I want to enable our register watch here. And so basically what we should see is it should break on writing to one of these registers before it gets to the end of this interrupt handler. And that's not what happened. Interesting. So I'm going to disable the register watch and continue and see if this happens again. See if we hit this again. So what just happened there is it was decompressing graphics, the interrupt fired, and it didn't clobber one of the registers, right? So there we saw a case where it was okay that the interrupt fired. So first of all, I think conclusively that proves that it's not the interrupt firing that's causing the problem. It's some other logic that is brought out by the interrupt firing. So, okay. So then we'll run this again until we get the sorry. 292, yeah. So these are decompression start and end. Oh, whoops, I just skipped it. Okay, that's annoying, but I think that'll be fine. Here we go. So here we hit the interrupt handler while we're in the decompression routine. And I'm going to do it again. So we're going to enable the register watch. And we didn't hit it. Here we go. And we didn't hit it there either. And now we're hitting interrupts outside of the decompression routine. So I'm guessing if I just hit continue a bunch of times, we're going to see a frame. And that makes sense. So now I'm going to disable that breakpoint. But I thought I've add breakpoint, remove breakpoint. I thought, okay, I could just type breakpoint, but or BP maybe. Thought B would just give me that. I guess it does. The 60 BC. I'm gonna add this end address here to my notes, because that's the one we're gonna remove. Interestingly enough, yeah, okay, that's the end of the interrupt handler. That makes sense. So we need to get rid of that too. There we go. So I'm going to go to a different screen. We should get the decompression routine, and then we're going to add these other breakpoints again. In particular, I really only care about the first one for now. Bang. There we go. Have that, and then we're going to add the one for the end. And then we're going to enable the register watch. Bang. So already found a case, and we found out where it is. So this is good stuff. Too bad it's too expensive, though, so I bought the LSR 308 from JBL. Which ones are those? Oh, yeah, a buddy of mine has those, actually. I think generally, with these monitors, you get to a point where like it's kind of, they're all pretty good. As long as they have enough low end, I find that's the thing most of them lack, including my own actually. But that's just because they're 5-inch. But as long as your sound picture is pretty flat, then it's nice. Checking out Daniel Collins' link. Taking a while to load, so I'll continue the bug hunting here. Oh, yeah, just some classic 4-inch monitors. Nice. I like gear. So this is where it happened at 8D4B0. And that's here, by the way. because again, this prints out the instruction after. So this one here, this AC, this is where it's happening. So this is going to clobber this and R13. What I think I'm going to do now that we've kind of isolated this, I think what I want to do is continue this little round. I want to do this a couple times and see if this is the place where it's always happening. And if that seems to be the case, then that's going to be a really important clue. And I think there's a lot of other code we can skip reverse engineering if that's the case. So I'm going to do that. So I'm going to disable the register watch, continue, and we should get the end of this. Dan Collins says, but the and instruction will write to it as well, right? Yeah, it should. But I think if it ran this code, then it's going to run this code. And as soon as any of these registers is written, then it's kind of all over. So I think it could be this one. It also could be these ones that are going to clobber it even more. But like we've already lost at this point. So I think I just want to see if this code path is the one that's causing us problems, I think is the best way to put that. But yeah, judging by the arguments here, this one will also write to it. That's absolutely true. And R13, and the next one as well, with R13. But that's another one of the registers we care about here. So, by the way, I appreciate it when you say it makes sense, because it's nice to hear that when you get into this debugging stuff. So we can remove. Actually, I'll keep that on there. Keep the breakpoints in that routine. And 494 is the end of the decompression, I think. Let me look up here again. Yeah, I'm actually going to add these labels here. Make this easier for me to see. One of the really nice things that I've seen in some other monitors. That's something else. We don't need that right now. Oh, why not though? But a lot of them will have, like, when you start up the emulator, they'll have a thing where you can, on the command line, specify a file, and it'll just read the lines of the files as monitor commands. And that's really nice. But yeah, this is why I wanted to put these in, so we can actually see where these are rather than just comparing the addresses every time. So here we had the int handler, but it was outside of the decompression routine. So this will probably just start displaying frames. And then we're not too worried about that. But avoids tool is getting big around 7K. Doesn't sound that big to me. Too bad says I like the sound of mechanical keyboards. I really like this keyboard. My cherry blues. I need to get my keyboard from the US though, which has reds. But I do like the blues better. So I want to, go through a couple cycles of this and see if we can get it to break again. That's what we're after here. Dark Second says blue is best, and I totally agree. Okay, here we clobbered a different register. which is interesting. In B92A? Is that anywhere that we have here? It's not, but this thing here jumps to this. In fact, let's do go F8 B924. And there we have it, which is this right here. Yep, this is the one. Okay, so let's just keep gathering these. They'll be able to look at all those. Tomko, you're both wrong. It's not about the brown. I have browns at work because my coworkers appreciate that a little more. Beggars, this console was a bit off stream there. Sorry about that. Thanks, though. Disuse came here. Is this JIT generated assembly? No, this is so on Thursdays I do emulator stream, and on Sundays I do demo scene stream. So this is disassembly of a Nintendo game that we're looking at in order to find a bug in this emulator. It's like Jeff says, Disuse, I doubt the Virtual Boy was that advanced. Although there's actually quite a bit of stuff on old school platforms, especially that at least use like manual loop unrolling, self-modifying code. A lot of that kind of stuff. So I wouldn't be surprised at least if that stuff was being used. But it would have been a bit silly with this much ROM. And this fast of a CPU. Would have been a bit before this time, I think. Like I know a lot of stuff from like Amiga and C64 were doing those kind of tricks. Apple II. Cowboy coding. Yeah, so there we got another write to those, which is interesting. And there, the same one happened. Okay. Yeah, same one here. Just out of curiosity. Whoops. This 01 we saw here is still 01 in this case. Just to dig into that. Also, there's a lot of stuff here now that wasn't here when we looked at this before. Which is somewhat interesting, because we had all zeros here before. Maybe relevant. It's actually in an alternate reality, the Super Java TM Nintendo. Sunper Microcom Systems. I guess it'd be Sunper Micro Entertainment Computer Systems. back in frames. And there should definitely be corruption here. And boy, is there. Oh, Mario's looking good. I'm actually going to let this go into the demo mode because I want to see if that clobbers different registers. Wondering if there's any kind of correlation between which registers get broken on which screens or something. Here we go. I'm totally not Googling those monitors on eBay. Okay. Decompression start, so we'll add the stuff for the interrupt handler. And there we had another one. .8145E. Wait a minute. Is that in here? Yeah, this is actually this is actually in the interrupt routine. So how did I mess this up? Because this should fire in here because this is the interrupt, or this is the decompression routine. Did I not add a breakpoint for the end of the interrupt? Thought I did. Weird. Oh man, dinner calling. Yeah, that's pretty pricey, but it's pretty cool that the shipping and everything's free. Man, that thing's gorgeous. .84D. This is the one we had before, right? .8D4, sorry. Yeah, that's what we had before. Same one. Same one. So I'm going to just add a note here because it seems like it clobbers here when it's moving away from the title screen. which I'm not sure if it's relevant, but it's something. It's a pattern, so I'd rather write it down. Come on, show me stuff. There it is. Oh yeah, no, I'd totally pay $500 for a monitor like that, to be honest. I mean, those are high quality pieces of equipment. Like it's outdated technology, but it's still so good for what it is. That is the Cadillac of CRTs. Especially with the smaller size, because it's like ideal for having on your desk for dev. So. Whoops. Whoops. Oh, dang it. What happened here? Oh, never mind. Here we go. This one I wanted to remove. Yeah, that's fine. Yeah, there's a couple things I need in the debugger, but a bunch of them didn't work well with MSys. Like the history and everything didn't work well with MSys. I mean, I could just use the normal Windows console, but yeah. So I want this to transition back on its own. Hey, Looks Online. Stream's been going for about an hour and a half. About an hour and a half. I'm gonna keep going a little bit longer. Oh, it broke there, didn't it? Or did it? I didn't trigger that, did I? Oh, it actually probably decoded some more graphics for this stuff. Let me step through a couple of these. Probably worth trying to get its trigger there as well. I'll have to see. You can watch on YouTube and then be frustrated when you realize you can't respond in real time. I get the feeling that comes from experience. Oh, yes. Yeah, Colin, when you buy your PVM, check out this place. Oh yeah, I'm familiar with retro gaming cables. Looks Online has much progress been made on finding the source of this bug today. I suppose. We're digging into what is actually what code is actually clobbering these registers. Yeah. That's just taking notes on that. Found 2 places so far where it looks like it's doing that. I can't remember where I got it, but I actually got a new power cable for my C64 from some French website. And it's actually like it has the header for the C64 power supply, but it takes the AC AC voltage from like a SNES adapter, so the 9 volts AC from that, and then the 5 volts rail just from like a standard switching power supply. That's pretty nice because I still don't trust those brick power supplies from Commodore. So those are pretty bad. Avoids name one system you don't have. Every Atari except the VCS. I have 2 of those. Yeah, so there we had no clobbers, and the graphics is perfect. Bagger says Altair. Yep, that's also true. PDP-11? Nope, not yet. Xerox Alto, also something I don't have. Great machines, though, guys. Yeah, it's the same place as that other place. Again, while we're going away from the main screen, so that seems to be consistent. Here we just got an in handler outside of the decompression routine. Oh yeah, we're back to showing frames again. Yeah, it did play Space War on a PDP-1 at the Retro Computer Museum in Mountain View. That was pretty rad. And actually, we ended up being there. So me and Baggers ended up being there on the same day that these guys who have been restoring these and repairing these were there giving a presentation about it. And one of them had actually worked on Space War, and another one had done this music stuff with one of them. And they got output out of one of them to a speaker by routing the lines to the front LEDs through a resistor ladder to the speakers and to an amplifier and everything. And so they had, of course, like the punch card programs that they wrote, and the guy found his original, someone had found the guy's original code in some box in some basement somewhere for that program that he wrote 40 years ago. So I was asking him about the system, and it was just an extremely cool experience to talk to this guy and how the music player worked and how it had to do timing and how because every instruction was so expensive that he had to like have different code paths in the code be the same length as other code paths in order to get so the timing wouldn't jitter too bad. It was really cool. Bagger says LEDs, lamps. Yeah, definitely true. They were proper lamps. Yeah, that was a sick experience. Very lucky to to have been there on that day. Maybe it wasn't that special of a day, but or like maybe they do that more often, but it was special. Ep.030. Yeah, this is that other one. Does this one only clobber when it goes to the main screen? Or title screen, I should say. I think I'm saying main screen, but I should say title screen. Yeah, okay, I did there. Because finding those notes, like if it only happens, if it breaks here when it's going to the title screen or breaks somewhere else where it's going away from the title screen, that's the kind of information that's going to be really valuable in trying to track down which states are, causing these code paths to be hit in the first place. Because it seems like it's not hitting both of these during a screen transition. Maybe it did when we were working on this earlier, but I don't think that happened. Yeah, we're broken here again. So I'm going to do a couple more rounds of this because I just want to be really sure about the data we're getting here. Pays to be rigorous. Yeah, so this seems to be consistent. That was outside of the decompressor routine, so we should be good here. And we'll do this again. Oops, didn't set it that time, but I think that'll be fine. Yeah, I'm moving to it. We get this one. Really interesting, actually. That seems to be consistent. I'm also disabling the watch between runs. So it might hit both of those during one of these, but it seems to hit at least one the first time all the time, and then another one the first time all the time. And I think that'll be enough to determine what is making these code paths actually run. It might even be the same thing, which I'm kind of hoping it is because, yeah, you never know. And again, there are small bugs in some other games as well. So if at the end of all of this we find that like some branch seems to be weird or something, then that would actually be great because it has a potential to fix a lot of other bugs. We'll see. We'll see what we find. No sense getting hopeful because you never know what it could be. But I think this is enough data gathering now for this that we could start analyzing this next. It's like, Jeff, would it help to run it side by side with another emulator that runs the game fine, see what differs, or would that be too cheaty? I think the biggest thing I worry about there is that because there are going to be small differences in how we emulate certain things, like certain timing differences, I don't think it's going to, I don't think we're going to get very valuable, it's going to be hard to pin down what exactly we're looking at between the two things. At the same time, a lot of other emulators, as far as I know, don't have debug consoles like this that make it as easy to actually debug this stuff in particular. At one point, when I was working on my Super Nintendo audio unit emulator, I had a couple bugs in one of the ad routines, and I was able to refactor Blarg's SNES audio unit emulator, at least the CPU, to use the same interface as mine. And I did do that where I ran them side by side. Actually, in particular, what I did is I ran my CPU within the context of his emulator because I knew that the stuff other than the CPU was more correct in his case. So I was able to isolate that and then run it there. But yeah, I think actually just that it's going to be too finicky to actually get valuable data from doing, it's going to be too finicky to reliably run them side by side, if that makes sense. Because there's going to be too many sort of free variables that, we're going to see so much stuff being different that isn't relevant to what we're looking for, I think. That's my gut feeling. So I'm not against that in the sense that it would be cheating. I just I don't think it would be that good of a strategy in this case. Drew2 said, one thing with my NES emulator was use FCEUX's trace output and made my emulator output trace in the same format and then diffed. Yeah, that's actually what I did as well when I plugged in my CPU thing. But yeah, I'm generally a little bit concerned that, especially with timing differences, that we're going to have so many differences in state that aren't going to be relevant in this case. Especially because I know that other Virtual Boy emulators are not that great. You know what I mean? It'd be a little bit different if I were doing a C64 emulator and I compared it against Vice, or a SNES emulator and I compared it against Hegan, because those are a bit more rigorous. But I kind of don't trust the other emulators now, after having done this and seeing how sloppy they are in some ways. I don't really trust those. Drew2 said, yeah, he relied on FCUX being really good. That's the thing. I just don't think that'll be the case here. But I think this is fine. I mean, it's taking a long time to actually find what this problem is. But that's just kind of where we're at with this project. I'd rather just continue this, though. I'd rather keep working on this, because I think this is cool, and I think it's fun to kind of dive this deep every so often. And I really hope we can find these bugs. So Dart2 said it's not taking long. It isn't if you look at consecutive, if you look at all the different streams and you cut out the bits where I'm getting started or stopping, then it's only been a few hours actually, and that's really not that bad for this kind of thing. Also, yeah, it's taking the time it needs to. Yeah, that's fair, and I agree with that. That's kind of my point. It's taking this long because I only stream once a week, and I'm kind of working on other stuff rather than this in the spare time. So I just feel like I'll keep doing this on the stream. Bagger says, yeah, this is cool. Can't wait to see this bug die. Yeah, this is one of the earlier bugs in the emulator actually. That's just kind of manifesting itself now again. It's like, Jeff, the feeling when you fix it is going to be worth it. It really is. Drew2, when you fix it, well, I'll get up and dance. Oh, I will. I'll run around my apartment punching air. Appropriately, of course. But yeah, I'm gonna go ahead and stop streaming for today, and then we'll get back to this next week. Hitman44 using Rust. Using Rust. But I'm also generally really happy with kind of coming up with these little solutions where we just hack something in the emulator to look at something like this little register watch thing I hacked. That stuff makes me happy because it's nice when that yields results like it looks like it did here. So, and anything that'll keep us from rigorously reverse engineering a lot of assembler is going to really help. Because again, there's going to be so many variables here that are changing that are not relevant to what we're looking at. So Daniel Collins is going to send me PVM pics. Please do, though. I do want to see those, even though I'm going to be super jealous. Because that's just awesome. And enjoy the monitor. I hope you at least watch some of my demos on it. But yeah, guys, thanks for hanging out, and I'll see you on Sunday or next week or some other time.